Okay, in this video, we're going to talk about solving equations that are in quadratic form. Now, in quadratic form means it might not necessarily be a quadratic, but it might look like it's a quadratic. And what I mean by that, to explain this, let's go back and look at a quadratic equation. A quadratic equation is of the form y equals ax squared plus bx plus c, where a, b, and c are real numbers. Your degree would be 2, and you would have at most 3 terms, and the last term would be a constant. So if something's in quadratic form, that means I'm going to have 3 terms, and my highest degree, or my largest exponent, is going to be double the middle term, the exponent of the middle term. Okay, so if we look at this example here, example 1, notice I have 3 terms. The last one is a constant, and the highest exponent is double that middle exponent. So this is not a quadratic. It's not a quadratic because the degree isn't 2, but it's quadratic form. And when something is in quadratic form, we can actually use factoring or quadratic formula or the same methods that we use when we solve a quadratic. We just have to take an extra step first to set it up as if it was a quadratic. So, and that's what we call substitution. Use substitution first to set up like a quadratic. Okay, so I want my first term to be x squared or something squared so it looks like a quadratic. So I'm going to do a substitution. And I'm going to say, you can use whatever letter you want, but typically most of the time in math, it's just historically known that a lot of people use u for this. So I'm going to say let u squared be equal to x to the 6th. I want to replace x to the 6th with u squared and rewrite this equation so that it has u squared, then a u, and then my constant. And this is the way we're going to set it up to do that. Okay, well, if u squared is equal to x to the 6th, then I can square root both sides to solve for u. If I square root both sides, I get the square root of u squared to get u, and then I get the square root of x to the 6th to get x to the 3rd. So now I'm going to rewrite this equation with u's instead of x's. So where I see x squared, I'm going to replace it with u squared. So I have u squared. And then when I see when I see x to the 3rd, I'm going to replace it with u. So I have minus 26u. And then I have minus 27 is equal to 0. Now we can solve this just like we would if we had a quadratic. So I'm going to go ahead and factor this because this factors nicely. So I have u minus 27 and u plus 1. That would give me the u squared minus 26u minus 27. So my u is going to be 27, or my u is going to be negative 1. But here's the thing. This is where some students make a mistake. They think they're done. This is not the answer. We're saying that u is 27 and u is negative 1. But the question is asking us to solve for x, not u. And we did a substitution. So although we're almost there, we're not completely finished. We still have to go back in and figure out what x is. Well, we said right here that u is equal to x to the 3rd. So that means 27 is equal to x to the 3rd, which means x is equal to 3. And then I have to do the same thing with the negative 1. We said u is equal to x to the third, which means negative 1 is equal to x to the third, which means x has to be negative 1. These are my final answers. So when you use this trick where you use a substitution to put it in quadratic form and then solve it like a quadratic, don't forget that last step. You have to go back in and resubstitute for x. And then you can always go back in and check by plugging the x's in, one at a time of course, into your original equation to make sure that it works. Okay, second example. Same thing. This is in quadratic form because if you notice, I have 3 terms. The last one is a constant. And then this one here is double this, right? X to the first is double the square root of x. Because remember, whoops, let me go back here. Remember that the square root of x is the same thing as writing x to the 1/2. So the exponent of 1 is double the exponent of 1/2. So this is in quadratic form. It's not a quadratic because it would be an x squared if it was a quadratic, but it's in quadratic form, so we can use substitution and then solve it like it was a quadratic. So I'm going to say, let u squared be equal to x. So that means u is going to be the square root of x because I have to square root both sides to solve for u. So when I square root u squared, I get u. And then when I square root x, I get the square root of x. So now I can rewrite my original equation as u squared, because u squared is equal to x. So I'm going to replace that x with u squared, minus 5u. I'm replacing the square root of x with u. And then I have plus 6 is equal to 0. So now I can solve this like it's a quadratic. So I have, when I factor this, I have u minus 3, u minus 2. So u is 3 and u is 2. Now we're not done. These are our u's. We're trying to solve for x. So I have to go back and say, well, I said u is the square root of x. So, and if u is 3, then what does x have to be in order to get 3? What would I take the square root of to get 3? It would have to be 9. And then do it with the other u as well. 2 is equal to the square root of x. So x would have to be 4. So these are my 2 answers. And you can always go back in and check to make sure they work. Now, something to keep in mind, because this equation had a square root in it, I want to make sure that the x's I get are positive, and they did come out positive. But if one of them came out to be negative for some reason, I can't plug a negative back into that square root, so I would have to cross that off as one of my answers. So it's really important that you double check your answers and make sure that they work in the original equation.